right, for the first question, we're going to calculate this area of this rectangle, sorry, this composite figure by dividing it into two equal rectangles. I could divide it like that, or I could divide it the other way by going up here. Either one is fine. I'm going to actually, because I think it's going to be easier if I go this way, even though it doesn't matter, you should end up with the same answer. I can divide it like that. So the length of this side is x, and the length of this side is w. So if we say that is area 1, it is going to be x times w, which is just wx. You could write it as xw if you want as well. Area 2, now this length is 2x. Now from here to here is w. So if I want to know the length from this point, this side, for that side, it's going to be equal to our 2x, which is the entire length of this side, less the w, which is going to be, then our expression is going to be 2x minus w. So area 2 is going to be w times 2x minus w. So when we expand these into distributive property, it's going to be 2wx subtract w squared. So the total area then is going to be the sum of these two expressions, wx is our first expression, and then plus 2wx subtract w squared. So then we can add these like terms. So this is going to be 3wx subtract w squared, or the other way we could write it is negative w squared plus 3wx. These two terms, these two expressions have the exact same meaning. So the next question. Here we've got a triangle. We're given the following information. We're going to call this the base. It's just upside down. So the base of our triangle is 2p. The height of our triangle is 2p minus q, or sorry, 3p minus q. And we require in the question the area of the shaded region. So that's what we require. So we're going to apply a formula, which is area is equal to base times height divided by 2. Now we substitute in, that's the next, substitute and solve are our last two steps in our problem solving method. So we sub in, so the base is 2p times 3p subtract q all over 2. So 2p times 3p is 6p squared, because p times p is p squared. 2 times 3 is 6. Subtract 2p times negative q is subtract 2p q. And this is all over 2. Keep in mind we're dividing both terms here by 2, so this is 6p squared over 2. Subtract 2pq over 2. And this simplifies to be 3p squared subtract pq. And there is our expression written, so this is our expression written as a difference. Now, the next one, the easiest way to do a question like this is going to be to divide it into a large rectangle and a small one. Now, the area of our large rectangle is equal to 3w times y, which is equal to 3wy. That's a w. Now, this smaller rectangle, well, this side is z, this side is z, and this long side is y. So this side has to be equal to y subtract z, which is equal to y subtract 2z. Right? So that's the length of this side, y subtract 2z, because from here to here is y, this is z, so we've got to take off that side, and this side, so this ends up being y minus 2z. So to calculate the area of this white rectangle, the area of the smaller rectangle, it's going to be 2w times y minus 2z, which is equal to 2wy subtract 4wz. When you multiply 2w times negative 2z. So the answer here is then that. So that's the area of our small rectangle. So to calculate the shaded area of the shaded region, what we're going to do is take the area of our large rectangle and subtract the area of the small. That's an L for large. And so this will be 3w y subtract 2w subtract 4wz. Now be careful here, and I really should, when I was adding before, I should put the expression in brackets. When we take off the bracket here, all the signs change. So this is 3wy subtract 2wy, which I'm sure you can see, but when you have subtract the negative, remember that's the same as adding a positive, because subtraction is the same as adding the opposite. So this is 4w, positive 4wz. So this simplifies then to wy plus 4wz. Now, to calculate the shaded region here, we have a circle, and for the circle, we have a radius. So we're given a radius. So I'm just going to deal with the circle at the moment. We're given that the radius of our circle is 2x. And we require the area of the circle. So I'm just dealing with the circle at the moment. So we require the area. And we're going to apply our formula, which is area is equal to pi r squared. So we're going to substitute in and solve as much as we can. So area is equal to pi times 2x squared. And so this is pi. Now, when we square this, remember that this means multiply by itself. So I'll just expand this, and I'll talk about the exponent laws when I do this. So this is the same thing as 2x times 2x. So this is going to be pi times 2x is 4x squared. And I'm dealing with the exponent before I do the multiplication, according to the rules of BEDMAS. So now, when we multiply 4 times pi, that's just going to be 4 pi x squared. And I'm going to keep it as an exact number. So that is the area of our circle. Now, the area of the rectangle is 3x times 2.5x. So 3x times 2.5x. And 3 times 2.5 is going to be 7.5. And x times x is x squared. Now, the area that's shaded is going to be the area of the circle minus the area of the rectangle. Which is equal to then 4 pi x squared subtract the area of the rectangle, which is 7.5 x squared. And later on, we'll talk about factoring. You can actually factor, but that is the answer that I want you to give for now.